Hello, everyone. Today is July 27th, 2022. This is the Kubernetes Data Protection Working Group meeting. Today we have a few things in the agenda. Fang will give an update and on the CBT, and I will talk about the working group cap, give an update, and after that, it's going to be open issues. What is the, oh, so Fang, you put this one under open issues?
Yeah.
Okay, all right, okay, sure. So we can get started. Let me go to Fang's slides. Yeah, go ahead.
Yeah, so I just want to give a quick update of the progress that we made in our design discussion. We will wait for Ivan to come back in the next. He's in vacation right now. He will talk more in detail about all the issues with the architecture and how we resolve the problem and so on and so forth. But basically, the new design now is that we have the CBT aggregated server. This is, remember back then, like in about maybe 1 year ago, more than 1 year ago, I proposed a proxy service for all the different source snapshots. So this essentially is that. So the CBT aggregated API is like serving as a proxy. This will be one server per cluster. And when it receives a different source snapshot request, it will directing it to the CSI drive that handle that particular volume snapshot delta. And that is the like an essential of the architecture, right? For each of these CSI driver who support this different source snapshot or volume snapshot delta, it will need to register you by create a driver discovery CR and provide all the information needed to contact to communicate with it. You're going to see at the bottom of the orange box, of the pink box on the right, there will be like a client config and all that stuff. So these are information that need for the CBT aggregated API server to contact the CSI driver to get the different source snapshot, to get the volume snapshot delta detail. So in a sense, so that is the architecture. When Ivan come back in the next release, we will talk in detail, but you can click on page 3. I can give you like a brief discussion why we still thinking this architecture still needs some change. One of the thing is that right now we still debating between our CBT team is whether we still need a volume snapshot delta CR, right? The green box on the left-hand side, whether we need that at all because when we create that, when the backup software creating that, it starts the conversation, right? But and then that CR being stored in the SCD. As a matter of fact, I'm thinking that we might not need that at all. Instead of putting that into a CR, we can simply put that entire content inside the GET request as a body on the GET request on that the arrow on the top of the screen. You can see that. So we still need some debating. We still need some discussion, but that is the update of what the project right now.
Fang, so you are basically saying, because this is not something user have to control anyway, so it doesn't really add too much value by presenting this as this type of Kubernetes API object. Is that what it is? So basically, backup, because the backup software knows what it needs. It needs to basically, this is like more like an internal to backup software. It will just construct this the thing, communicate with. But then
I have a quick question. That CRD is actually the interface for pulling all the differences. If we are not providing that, basically the end users or backup software, they need to switch from the KIM model to REST API. Is that a desire?
I say we're still debating it.
But if you're
100%
using
sure.
aggregated API server, you probably have to do this, right? That's the part that
That's
no.
different, right?
Well,
Because the interface is still the CR.
Otherwise, how do you
That's the
communicate? It's a Kubernetes. You use the Kubernetes way, right? Otherwise, this is completely.
Kubernetes provides REST APIs.
I'm sorry, who?
This is Dave. Kubernetes provides these REST APIs. I think what we want to do is we want to make sure that they can be accessed through, for example, like client Go. So it looks like, I mean, that's normally the way you access things, right? Is client Go forms up a REST request formatted like this. I think the interesting thing we could do is like, I would really recommend that we keep the REST API as the Kubernetes API. So we don't add things that client Go can't generate easily. But we can do, yeah.
I agree. I think
because you don't want to write a straight REST client. You want to be able to say, no, I can use this with kubectl even, because kubectl will generate the correct REST. It generates a particular style of REST call. It knows how to form it, you know, for example, like with a field selector or something.
And that's one thing. The other thing is that how do they keep track of things, right? Well, if it's a pure
like
REST
what?
call, if it's a pure REST call by passing in snapshot handle, there's no easy way for the backup software to see, oh, I have done this, right? If it's a CR in the cluster, they can always query, oh, I have done this before.
I don't know if we need to keep track of that.
Yeah, so the setup, so like the change block delta resource itself isn't doing a whole lot unless, oops, I'm sorry, I'll be back in a minute. I've got a repairman here.
Can I ask the question? I'm sorry, I've missed this thread of conversations for a few weeks, but I thought the main problem with the CRD design was that these CRs can be potentially very large. There's a lot of churn for them, so it's not practical to store them in etcd. And because of that, we went down the path of using the REST API.
Arden, yes, that's fine. We're not looking to use the CR or the change blocks. Only the request, right? Only the two snapshot handles needs to pass down to the CSI driver.
Okay, and so when I look at this green rectangle, I see, you know, offset, I see very block specific information there, or maybe no, that's, or is that like or are we going to have like a different, look, for example, in the status clause, we have change block deltas, and then there's offset 0, offset 1. Are we going to have like a section for each offset?
No, my understanding is that in the status, that CR will carry the endpoint the backup system needs to hit to get all the change blocks out. It will not contain all the actual change blocks, unless I'm wrong.
So
no,
yeah, so I think
the
you're probably
CR,
not. Yeah,
the CR is now is not even needed.
Well, so there's, I think, okay, so there's a basic misunderstanding that is going around, I think, and that is, what's the relationship between Kubernetes resources and REST calls? And when you access Kubernetes resources from the API server, you make a REST call. Is that?
No, I think that's well understood. The question is really.
Well, no, it's not, because people keep having these questions. So this REST call, when we do the aggregated API, what happens is you retrieve resources from the API server using a REST call that then forwards it to the aggregated API server to satisfy that.
I have zero problem with that. I think
from the user's point of view, there's a resource that they're going to retrieve. And they can do this, for example, kubectl get volume snapshot delta, but they're going to have to do like a field selector or something so that the right stuff gets passed through to the back end. So you can't just list all change block deltas because that would give you every delta between every snapshot in the system, and that makes no sense. So that's going to have to return like nothing.
Okay, maybe I misunderstand because I'm not able to look at the screen. But what I was asking is, when we trigger the change block call, there still will be a CR, right?
It's a Kubernetes resource, so it's not a custom. So that's where people get pedantic, because it's not a custom resource. There's no custom resource definition involved. Because
even when you request, the first time you request it.
But
It's a
David, we look at the
resource.
screen, right? So okay.
It's a resource.
Okay,
So if you say custom resource, people go, oh, it's not a custom resource. It's a resource, though. It is a Kubernetes resource. It's just not defined as a CR.
Can you look at this? Can you see the screen?
Yeah.
Okay, because I think Shannon cannot see the screen. Maybe you can explain this one. I'm also getting confused with this one. So this one is a CRD, right? This one, what we are seeing here is a CRD.
So I'm just going to be pedantic for a moment, and just so we put this to bed. So there is no custom resource definition. Custom resource definitions set up things in the API server so that the API server understands it. There is, however, a Kubernetes resource. It's just not defined through the CRD mechanism. So the box in green, the volume snapshot delta, is a Kubernetes resource that you would retrieve. It's just not a quote unquote custom resource. You can call it a custom resource, but if you start talking to people and you say, I'm doing custom resource, they go, well, wait, CRDs and aggregated API servers, those are different. They act the same from the client's point of view, except for the lack of a CRD. So you retrieve Kubernetes resources using the naming convention, and they come back as looking like Kubernetes resources. So it's just the custom
if you're
part.
doing a kubectl, are you getting this? If you are using a kubectl command, you construct the same thing. You construct the same thing.
So
like
the way I saw it was, if the kubectl, you would select, for example, like namespace, your namespace / change block deltas, and then you would give a field selector. And the field selector would have enough information in it that the aggregated API server can talk to the right CSI driver. One way you could do that is you could define fields in the volume snapshot delta, such as base and target. And so you could give a field selector where you say base equals snapshot X, target equals snapshot Y.
Okay, so are you saying basically this is when we do a kubectl, this is not what you construct with the kind spec.
So you're going to get that back. You're going to get back change block.
This is only in the response. This is not in the.
So there's different ways to do it, right? So there's the concept of doing it all in like volume snapshot delta. In which case, I think you might. This would be where it comes back in the status. So you would create volume snapshot delta. You'd post that, or kubectl it, and you'd create it, and then you could check the status. You could retrieve the status. Fong was saying that the information here in volume snapshot delta is not something you actually need ahead of time. So creating the volume snapshot delta to kind of prime the driver doesn't actually help you out very much, because most of the setups we've seen, you can just say, hey, I want between this target, between the base and the target, and offset into your list this much.
Yes, that's exactly what I meant. We don't have to create a resource in advance. We just do it as a part of the.
Okay, so I guess a part is just I'm still not that familiar with how aggregate API server works. I thought so. What I see missing from this diagram is, where is the API server?
It should be in between backup software and CBT API.
Yeah, you should actually add that. Fong, can you add that, because that's part of that field. It's missing. So.
So that's if we want to get a Kubernetes standard API, which I believe is what we want to have. Is we want to look like standard Kubernetes.
I thought that's what we are talking about, right? Aggregated.
Yeah. That's what it is. It's
right.
Standard.
And so I don't want to talk too much about constructing REST calls, because the client should do that according to the Kubernetes spec, not through something that not through some extension we've defined. I think if we can figure out how to fit things into the standard Kubernetes mechanisms, we're going to be much better off. So like fetch CBD is probably not something we want to have, because that's custom for this. using like a field selector that gives us the info that we need would let it be generated by client Go or Java client or whatever we have by saying, here's a field selector, or by kubectl by saying, here's the field selector I want you to use, or something like that. So that's the challenge, I think, is figuring out how to put things, how to form a Kubernetes request that will go through the API server, get to the aggregated API server, and have all of the information that we need to pick the right CSI driver and the right information to give to the CSI driver to give back what we need, which are the change block delta records.
So far, I think what would help is if you actually, add that, API server there, adding those steps.
Yeah,
and also-
definitely.
Also, in the beginning, can you also add well, you take the first snapshot by, you create the volume and then take the second step, even that one, including that. So we see the whole, all the steps, because otherwise you jump to here. I believe there are some things that you are familiar with, but other folks are not very clear.
I understand. Yeah, I just want to give an update because when Ivan come back, we will present it more.
Okay. Yeah. So I'd like to
properly.
see the details.
Yeah. Thank you for the feedback. I will take this feedback.
Okay.
And discuss with Ivan on more detail. Like I said, this is still just like a quick update, and I don't want to get into much detail before he come back. So I think I just give an update for now. I think I'm done with my my update.
Okay. All right. Thank you. Let's see. Okay, so basically, Adlan, you're saying this was kind of written in there. It says it's different from customer sources, new kinds of objects. Okay.
Yeah, I think it's accurate to say it's a different way to add new kinds of objects. Aggregated API server and CRDs both have the same effect, that you wind up with new resources that appear to be there in the API server.
But it will be good to show, like, for example, in the first, you create a volume snapshot, then create a second volume snapshot. Those are customer resources, right? And then, then the third step after that, the backup software will want to get CVT. So what does it do? Does it construct some, just directly construct? But this one is going to go through. I thought it's the API server will do some conversion. That's what I thought. So, but that part I'm not clear. So
the API server should be in between. Otherwise, you're not really doing aggregated API. You're just
right.
doing a
So
REST
that's why
server
I'm confused by looking at this one. Right. So this is like a different server. It's not API Kubernetes API server. So it's very confusing to see like it's this line directly come here. Yeah. Just adding those, like a backup software constructs what, talk to the API server, and then API server does what, right? So that part is missing, I think. And it sounds like whatever you have here, this is the response. And also like this response is going to where? It's not like so this step is that direct. This is the returning step does not involve API server. Is that right? So this will directly go to backup software.
I believe it goes through the API server because the API server is essentially acting as a proxy.
Okay. All right. So then we need some details, because then that if you look at the, what Adlan was asking was why we are having all of this delta in the status again, because then we are not solving the performance problem at all, because all of this showing up in the API server, right? So that's the question we want to see.
It never gets stored in the API server. It just appears from the API server. Just think of the API server as acting like a proxy here.
Okay.
So it's a pass.
So
no matter which style we take, it's going to be a proxy and just pass the data back from the aggregated API server.
But it's going to be saved in the aggregated API server though, or what?
Well, the aggregated API server can generate it on demand by calling the CSI driver.
So it's basically not saved anywhere. It's just like generated on every call. This will be generated basically.
Yeah. So the idea is to pass it through the CSI driver, which actually stores all of it, right? It doesn't even, but the storage system knows how to generate it.
Okay. So basically, every call goes through the storage system. There's nothing kind of stale, right? Like when you do in general, when you do in Kubernetes, when you do some kubectl get, those information are kind of in API server. In this case, every call actually will have to go call the storage system to retrieve it on demand, basically.
I mean, you could build a cache in, but that's an implementation detail.
Yeah, but that's the thing. Yeah, I was just saying that basically it's like you have to get it. It's not like something it's there. It's not like the kubectl or get PVC, that's already there in the API server. But this information is not, basically you have to retrieve it from somewhere, not from the API server.
Right. So performance on that is somewhat of a concern, but I think we're talking seconds, not milliseconds.
Right.
Is the performance.
Then we can do a cache if you have performance.
But I think it should be, with a decent. I don't know. I don't have to work on Vista anymore.
maybe that's secondary thing. We can consider that. We can think about later. Let's figure out all the communication between backup software, API server, and aggregate API server first, right? Let's make sure everybody is on the same page on this one. And then this, additional performance issue, maybe that's secondary. Yeah. Okay, I think that's it's good. Adam, you want to say something, or you just want to put it there?
Yeah, I was going to ask the question. So I shared actually a link in the chat, which kind of talks about look, this is more about authentication, but it kind of puts in picture, where the aggregated API server sits relative to the Kubernetes API server.
Yeah, this is actually, this is good, right? So this actually shows you where they are. Oh. Okay. So in the middle, this is the API server, right? In the middle.
Correct.
And then on the so fine. Yeah, I think this is a good diagram. Something to show all three. I'll just add these comments.
Yeah, and some of the good things we get out of going through the API server is like the authentication step there, right? That all happened in the API server.
Yeah,
so
that would
we
be
don't
nice.
have to
that
do
you get that for
authentication.
Free, right?
Yeah.
So sorry, one thing that wasn't clear to me was this API server extension thing. Is that going to be the CSI driver, or is it going to be also another proxy to talk to the CSI driver to get the change blocks?
Just another proxy to talk to the CSI. The thing on the left, on the right hand side, the green box and everything, is still similar to what we've been talking before. That we still enhance the CSI driver vendors still need to enhance their driver to support these different source, the Delta. And you can see those two blue box right there is what the mechanism for us to eventually call the CSI vendor to support the Delta, to get the Delta from them.
Okay, so we have basically two proxies, from the backup software, it goes to the Kube API server. From Kube API server, it goes to the aggregate API server. From aggregate API server, it goes to the CSI driver.
Yeah, that's it. The two hop that we're trying to see if we can reduce. Right now, we need to do that two hop because the CBT API, aggregated API server cannot talk directly to the CSI plugin.
Yeah, that's like a requirement. Aggregate API server has to be singleton. So yeah, so you have to have this one. This is like a central one, and then you have
that's the like the
for
proxy.
each driver. Yeah.
Yeah. The blue box in the center, it will be one per cluster, and the blue box on the right is one per CSI drive.
Right.
Okay. All right.
Again, I mean, we will come back 2 more weeks, and Ivan come back, and Ivan and I still need to work to figure out all the detail. We haven't got that far yet.
Did you look at Yang's comments? He has some links. Is that the same as?
Yeah, I have. I think I read the link, but I haven't spent much thought on that yet.
Okay.
Yeah.
Right. Okay. Anything else on this? If not, then move on to the second topic, which is the voting group. I just want to talk about this. I have a question that I want to ask folks. So I think we looked at this a long time ago. but I updated the cap recently. Well, actually, not recently, it's been a few months. So now the API part is more like it's more like the PVPVC, volume snapshot, volume snapshot content, that type of model. So basically, we have a volume group, we have volume group class, we have volume group, we have volume group content, right? So basically, we have 2 API objects for each API resource. So similarly for the group snapshot, we have a volume group snapshot class, and then there's a group snapshot and group snapshot content. So there are some concerns that we are making this too complicated, that we need to have 2 API objects per resource. So just want to make sure that we cover the use cases. So if, let's say, if we only have one, if we only have volume group, but we don't have this volume group content, does that meet your use cases? I believe that's the thing that I want to figure out. Now, the reason that I want to go with this model is because this is a kind of a same model as the PVPVC and volume snapshot content. So this supports static provisioning. So if you have a, let's say if you have a volume group on your storage system, you want to just import it, right? That's a static provisioning. Then with this model, you can support that, because in the volume group content, you can specify the handle to the volume group on the storage system. Admin creates that, and then the user can create a volume group to have that bind with this volume group content. It's kind of very similar to PVPVC and volume snapshot content. If we only have one object, then we won't be able to do that, because you're not because this object will be user space. You're not supposed just to directly put your volume group handle, which is a handle on your storage system, directly into a user object, right? So if you want to import a particular volume group handle, it doesn't make sense to add that directly in a user spaced object. So meaning that if we only have one API object, then we couldn't support that particular use case. So I just want to know, how useful is that? How important is that use case to do static provisioning?
Static provisioning of what? Sorry, I lost track.
Oh, static of a volume group. So let's say if you or maybe we can think about this one like group snapshot, right? So let's say some storage system, they support consistent group snapshot. They have this on their storage system. So thinking about you have a snapshot on your system, or you will have a volume on your system, is the same thing, right? This is assuming that you already have this on your storage system. Of course, if you don't have that in your storage system, then that's a different story. Let's say if you have a consistent group snapshot, you have this created on your storage system. You want to import that into Kubernetes.
Yeah.
Is that clear? So basically this is
so
the same concept as let's say you have the you have a snapshot created on your storage system. You want to say, hey, can I manage this snapshot in the Kubernetes, right? So here we're talking about group snapshot, but it's a similar concept. So is this an important use case, or is it okay that we do not support this use case? We only support dynamic provisioning. Or is that, I guess it's...
So for restore, if we need the volume group snapshot to create volumes from, then in the DR scenario, the everything's gone. And so we have to do static provisioning in order to have the snapshots be present so we can create volumes from them.
So you're saying in that case, the group snapshot on the storage system, that's something you are trying to basically do the restore from? That's what you mean?
Yeah, yeah. So
So
the
you
question
don't
would
have
be,
anything. Oh, I see what you're saying. So you say, I take a group snapshot. It's kind of my, for my disaster recovery or for my backup, whatever.
Yep.
Now your Kubernetes cluster is destroyed. I
Yep.
want to restore that back from my storage system. How do I do that? So I need to be able to somehow import this particular group snapshot ID into Kubernetes so I can use that again. I can restore from that, something like that, right?
Yep.
I see. Yeah, I think that's a good use case.
So the question would be,
write down.
does volume group snapshot, is that actually a necessary thing? So are there systems that will only do volume group snapshots, or could you do a snapshot with a volume? I don't know.
Well, let me
I guess you need to. Anyways, yeah.
Okay, let me just write down this use case. You're saying that to import group snapshot ID for DR or something. I'll just add this one. That's know what do you mean? Okay, go ahead. What is?
Yeah, I guess. I mean, you may not need to. It depends because you've got like a list of volume snapshots. Are
right. That is if you. Right. That is if you do not. But okay, so in that case, you're saying then you just import those individual snapshots, right?
So actually, I guess that does the right thing though, because if you have a volume group snapshot, you would the logical operation is you can create volume groups with that as the source, right? And then that not only creates the volumes, but it also groups them together.
So yeah, okay. So I think that's the thing. Actually, I think in the first phase, we're actually planning just to support you to like do individual restore, like create a volume for snapshot. So for that case, actually, I was just talking about this is like phase one proposal. In that case, you probably don't need to import the group snapshot. As long as you know your individual snapshot handle, then you can actually restore that. However, I believe there are some storage systems does not actually return the individual snapshots. I believe Ceph, I think there were some discussions on that cap. So I believe what I learned is they couldn't really return the individual snapshot. So they will only have a group snapshot. In that case, that's the only way for them to restore. Right. So maybe I'll say.
Yeah, that makes sense. And also, I mean, in order to get back to a working system, so our goal is to be able to create a cluster that's functionally identical to the original one. So I really think we need to be able to recreate the volume group because, if your backup, cluster, gets hit by a meteor, restore, but now when you go to backup the restored cluster, the volume group isn't there. So somebody's got to recreate the volume group in order to get correct backups after you recover.
I'm sorry, I was typing.
I think it depends whether your system need the volume group to function, right?
Oh, you're saying the volume group. Okay, well, yeah,
backup
also
continuing backup is functioning. So when you restore the cluster, if you can't keep doing backups the way you were doing them, then you've got to fix it so you can. I mean, are you
talking about are you saying like we also need to kind of import the volume group if that's there on the system? Is that what you're saying? So that we can continue.
Yeah. So like,
let's say if we want to continue to do this, let's say periodically we are taking a group snapshot from a volume group. So when we restore our system back, we want to be able to do that again. So we want to be able to get our original volume group back. Is that that's what you mean?
Yeah. So it needs to be grouped. Otherwise it's not going to, otherwise your backups as you move forward are going to be incorrect. Right. So I don't know if it needs to be the original one or a new one, but it just needs to be.
You get a volume group back.
There has to be a mechanism for that. Otherwise.
So this one, is that maybe, this is maybe all right not to have that because you can, your YAML files are there, right? That you can, probably should be fine. You can create that YAML file again, then to create a new group. You probably don't need to import your original.
You may not,
Right.
but I think we just need the workflow though. What's going to
Mhm.
happen on restore so that you get back to a working state and just work through what steps you need to go through and whether those are easy or hard.
Mhm. Right, so this one might be okay. I was thinking this is a problem, this one, because they don't have individual snapshots, right?
But Xing, on systems that support both regular or individual snapshots as well as group snapshots, is a group snapshot going to be represented by a collection of individual snapshots, or is it going to be, for example, like for a group snapshot, is it going to point to a bunch of, let's say you have a group snapshot content, is it going to point to a bunch of regular volume snapshot contents, or is it going to be like more self-contained, more independent?
There is a, so for in every so for the system that will return the individual snapshots, so in that case the snapshots will have a reference to the group, so they are kind of, they're related. And in the group snapshot also, they will be in the status, it also has should have a list of snapshots, so it's like the information should be stored. So they so they are not like completely by itself, because you're not supposed to, you should not be able to delete the individual snapshot if they are in the group, because otherwise, then maybe at restore time you have some problems.
Okay, so the group types are a collection of individual types, whether it's group snapshot or volume, so whether it's a group snapshot,
But
group,
the
group snapshot or a group volume group, they both are a collection of it.
The difference is like for the volume group, you are allowed to remove a volume from a group, right? You can do that. But for snapshot, it doesn't make sense, because when you take snapshot, that's kind of frozen, right? You need to have that one to do your restore. That's why there's no way for you to just say we're not going to provide API for you to, let's say, remove one snapshot from your groups, remove one individual snapshot from your group snapshot. That's not going to be there. That's because that's not allowed, right? It just doesn't make sense.
And what's the relationship between volume group and
the volumes?
Volume and snapshot groups? Are they related? Like when you take it,
when you take a group snapshot, you take your source is the volume group. Okay,
then the volume group definition changing may have implications too for snapshots. Look, I understand you're saying that snapshots are
so it's only, so when you restore it, of course you will only restore back whatever, at the point of time you take a snapshot, right? So you say I have 10 volumes in my group. When I take a snapshot, then when you do a restore, then you should have 10 volumes, even though after taking the first snapshot, you have already, say, deleted 2, right? Then that's your next snapshot, right? So they're just thinking about the same way as if you make changes, to your volume or not. So every point of time, your snapshot could be different. Right. So yeah. So when you restore it back, definitely it really depends on how many volumes were there when you take that snapshot.
Okay. So basically, we're saying group snapshot or group snapshot content becomes decoupled after we take the snapshot from the volume group.
Kind of. You can still yeah. It may not have the same one-on-one relationship anymore, right? Afterwards, because you can modify your group. Yes. Then you can use your group snapshot to create a new. The reason is you have the group snapshot, is you could create a new volume group. Right. We're not talking about right now because we're not supporting the in place type of thing anyway.
Okay, so I guess back to Dave's comment that it depends on how easy or how hard it is, the process. I think given that a group snapshot maps to a list of individual snapshots people can individually restore their snapshots, but
You
that's
could,
painful
yeah,
for them.
we do.
That's painful.
So we
So-
do allow them to, yeah. So we do allow them to restore individual file, like individual volume. That is okay. But what I'm saying is, you won't be allowed to delete that from your group snapshot once that's because if you the reason you take, because there's a difference between the relationship between a volume and a volume group and the relationship between a individual snapshot and a group snapshot, because volume can be dynamic. A group snapshot is not dynamic. It's done, it's fixed.
Yeah, that's fine. That's okay. That doesn't have any implications on restore.
Yeah, restore should be fine. Yeah, I was mainly just want to see if to see if it is if we can just have one object, right? So if we want to support this case, it looks like it's not possible. This just looks like it's not, because they don't really have because the only way for them to restore, let's say if they want to do this importing, then they have to import that group snapshot, because they don't have individual snapshots to import from. That's the thing, right? So if they want to.
I have another question related to this volume group snapshot. It does conceptually atomic or individual lab snapshot, or belong to this volume group snapshot, can be accessed, gradually, or
so those are all depending on the backend's implementation. So initially I was trying to say, hey, we have this consistency group, but then there are some problem of like, if we want to really enforce that in Kubernetes, there are storage systems, they all behave differently. Some storage systems can support consistent group snapshot, but others cannot. So what we do is we just say, hey, this is our volume group. Then we'll leave it to driver to interpret, whether they want to claim their volume group is consistent or not. That's their thing. We just provide a way. We just provide those APIs for them to, yeah.
So it's up to the back end to guarantee
right
that,
because there's no way for us to guarantee, because already there's a lot of tricks, right? It could get things wrong, right? If let's say you have two volumes, they are not in the same storage pool, then maybe that then maybe the storage system cannot support consistency, right? So that's the type of thing we don't know, because every storage system is different. Yeah, so we don't
from a backup vendor point of view, right? When we can say that it is safe to start using the content of this volume snapshot, like is that, are you going to change the status to ready, or what, when the volume
right
snapshot?
Yeah, so there are status like that, right? So there will be status like to say I have finished adding this volume, and then we need to change the status. There's a status update. So like the current design, that right now I have two objects. So if it's just one object, then we need to tweak the design. But the API have a status field. You can take a look and see if this one is being added or not, and then you can look at, there is a list of the PVCs. So that's the current proposal. Of course, the design is still up to subject to change, but yeah, there will be indication there to say, hey, this is ready, not ready, or something like that.
So back to my earlier comment about how these volume groups or volume group snapshots are implemented. One of the arguments in the early days of Kubernetes storage for having this dual object model was there may be sensitive information within a PV, or let's say volume snapshot content, that is, we don't want to expose to users, regular users. That was one argument.
Right. That was
and I think.
Right. Okay.
And I think if these group objects like the volume group snapshot or volume group, they are just pointers to PVs or pointers to volume snapshot contents, then I think we're okay as far as security, because they're just pointers. They don't really divulge the content of those objects.
Yeah.
So we can possibly even go with a single object model. And as far as basically as far as security, we're okay with single object model as long as how we refer to, if we construct these group objects as a collection of individual objects, so basically there's no security problem if you go even with a single object model.
Yeah, so there are, I've kind of seen those. I know there are some storage vendors, they have kind of already implemented something like this, right? So I see some of those implementations are pretty simple. They just kind of use the PVCs directly. It's there, right? They have a very simple way of grouping them just using the labels. That's a very simple way, right? But of course, like, there's some other use case that we talk about that may not be able to support, right? So if we only rely on the existing PVCs, then of course, right, maybe we don't have additional information that we need to get exposed in the user object, then that maybe one object is enough, right? Yeah, so that's one argument there. So if we can just group, just into existing. Right, so just want to make sure, like, either way, need to make sure we can meet those requirements. Does anyone else has any comments? Hey, Tom, I see you're there. I remember you were interested in voting group a while back. I just want to see if you have any comments regarding this. Tom Watson. You're on mute. Fang, do you know this? Like, I know you guys are interested in this voting group a while back. So
yeah, I was going to say, let me review it and get back to you. We do have an implementation. So
you do. That's awesome. Actually, it would be good if yeah, then we can see what you have learned from your implementation. Yeah,
we only use one object.
use one. Okay, cool. Do you have both? Do you have both group and group snapshot, or just one?
Just a volume group snapshot.
Okay. I think that seems probably more like I know Portworx has implementations. They just have a group snapshot. So yeah, so that's something we could also consider. That's more simple approach. I know HPE has an implementation. I think they have two. They have both. Yeah. So yeah, please get back to me when you get more information. Yeah, good. I'd like to take a look and see, what we can support, what we cannot support with one object.
Yep, sure will. Took a note to do that.
I'll add your name here. Just say action item. Thank you. Any other comments on this topic? All right, if not, then we'll move on to the last topic, Fang.
I think we only have a few minutes left, so I'm not sure if we want to start the discussion here.
Okay.
But the idea was that remember we when we do the CBT, we start the conversation about the API, very enhance to the CSI API for a long time before we can actually do something about. So I want to start the conversation again for the file chain list, similar to the chalk the blockchain list, in which for many vendor out there, storage vendor, they export their PVC file system PVC on the back end. This could be a national file system volume on the back end. So for that, to do effective backing up, we just need a list of files that have been changed.
Mhm.
And I've done some research. I found that, like PowerScale, for example, Dell PowerScale, it have a way to get the chain list information, right? Which each item in the chain list only specify the what type of chain it is, and the path, the file path, and so on and so forth. And if we backup vendor can get a list of chain like that, then we can simply back up these files instead of walk through the whole snapshot and backing up, try to check everything manually. Checking up individual one by one by a tree walk or something like that. So we kind of on a few minutes, I may not be able to present the entire thing. So and also I have some network access issue. So I rather start this conversation maybe in the next work group meeting.
Okay. You want me to move this on to the next meeting?
Yeah.
Okay, sure.
The next meeting.
Yeah, I'll do that.
Yeah, the goal for that would be maybe we can settle like a CSI spec for that chain. For that chain list to say how it look like, and then all the vendor who want to support the CSI spec would able to implement that, and then any vendor who want to backing up effectively, can do that CSI enhancement.
Sure. Oh, did he just got dropped? Oh.
It's just basically very
Oh, he's
similar
still
to
here.
the
Okay.
CBT.
Okay. Yeah. Sure. Okay. Yeah. Okay. Yeah. Well, I'll move this one to the next meeting. Yeah, we're gonna have like 3 minutes. Yeah. All right. Anything else? Okay. That's it for today. Thanks, everyone. Bye.